Yes, please. Yes.
All right. A final voice check. Is everything good to go? Am I audible clearly?
Yes.
Yes.
All right. Thank you. So let's get started. Now, let me already warn you that this is going to be a fairly involved and a fairly condensed talk, because a lot of the content that I'll be going through can it themselves become a workshop and may take a day to complete. So I hope all of you are geared up for this event, and my goal with this event is not to give you the very basics of TDD. You'll see me doing the basics, but then very quickly I'll start switching over to the advanced concepts. So I hope you have fair amount of experience working with object-oriented systems, maybe Spring, maybe some mocking libraries like Mockito, because all those tools I'll be using. So yeah, let's get started. So first and foremost, we are talking about software craftsmanship here. And how do we define a software craftsperson? For me, the attitude comes before the skills. Okay, which are the attitudes which I think are really important? Now, this is my personal opinion from what I have felt through my experience. You may have your own opinions on this. So one of the most important things I think for a software developer or software craftsperson must be humility, because uh, there's so much to learn in this industry. Nobody being an amount of years of experience in an industry, you still have not learned a lot of things. So there's still a possibility that a junior that you may have recruited may teach you something. So that should give you that the feeling of humility, and that grounds you. It is very important for a software craftsperson. Then empathy, because you would want to empathize with all the people that you're surrounded with, be it your junior, be it your managers, or be it your customers. So if you don't have empathy, we will never be able to step in their shoes and look at the world from their perspective. Then obviously we are in an industry that is fast growing. It is changing at a very fast pace. So if we don't have a growth mindset, we'll get stuck and we'll find ourselves into the weeds. We'll think that, okay, my knowledge is no longer relevant in the industry. That's why this applies on a macro level as well as a micro level. On a macro level, it can be about the technologies or the tools that we are using. On a micro level, it can be about the coding practices, right? Whenever you open a class, you always see some scope of improvement that you can make inside it, and that's where TDD helps you in making those improvements, because you always have the safety of test cases. Then mentorship, they should always be ready to give back to the community. So it can be either open source, or it can be like a personal mentorship. You don't have to give a definition to it. It's just that you need to have an attitude to give back. Then comes the skills. From my personal experience, what I have felt is good typing speed is the most important skill that any software craftsperson must have. Because if you are still fumble when you are typing on a keyboard, then you'll obviously not get much done. Even though your thought process is fast, you'll not be able to put that thought into the coding very fast. So you need to be very good at typing. Then you should have excellent command over tools. So be it your IDE or be it any library or tools that you are working with, we need to be like super users of those tools. Then obviously the topic of today, which is test-driven development. Then you would have pair programming, which is also one of the important skills in extreme programming. Won't be touching upon it today, but it's an important part. Then the ability to wear different hats. So when you're writing production code, you're like a developer. When you're writing a test case, you think like a QA. And then when you're writing user stories, you think like a BA or a customer, right? So you should be able to think from different perspectives. Now, I'm not going to lecture you on software craftsmanship. You can always read Sandro's book, The Software Craftsman. He has said a lot about his personal experience over there. Okay, so let's dive into the testing topic for today, which is the first we are going to introduce and see what types of different testings there are and what particular type of testing we are going to focus on. So the agile testing pyramid has quadrants. Is like you have 4 different types of delineations. You have the test cases, which are technology facing, business facing. Then you have support, which support programming and which critique the product. we will be working in this quadrant, which is quadrant 1, where you have unit integration, component and system testing. They are fairly white box, so you are working closely with the technology. Okay, you know about the internal details of code, and while they are also useful for supporting the programming, so they help us in refactoring, they help us in making the design better. So that's our focus for today. But there are other quadrants into the pyramid which are equally I mean the other quadrants of agile testing which are equally important. You cannot let go the acceptance testing or the usability testing, the manual testing, as well as load testing or security testing. So all those aspects are important, but our focus is going to be on the testing practices that help us in programming and are fairly white box. Okay, so before we talk about unit tests, there is a first principle that we need to understand, because this is where most of the people get unit testing wrong. So first is an acronym. So F stands for fast. If a unit test case is not fast, then it is not a unit test case. So it needs to run in order of milliseconds. If it is a slow test, if it is waiting for something, then it is probably touching an IO, or it has some other dependencies. That's why it's not able to run fast. So the test cases need to be fast. Then they need to be isolated and independent. This is one of the most important points, because you want your test cases to be able to run in parallel. Okay, so if your test cases are not isolated from each other, they are maybe sharing a common database or they are sharing a file system, then they are going to step on top of each other. That's going to stop you from parallelizing them. So always make sure your unit test cases are isolated. You don't have any anti-practices like static variables over there, so that you can parallelize them. Then they should be repeatable. If I run a test case one time, or if I run it n times, it should always give me the same result. It should not happen that it passes sometimes and fails. So those are called flaky test cases. You don't want them. Then they should be self-validating, as in you should have proper assertions. So it should not be the case that you run a test case and you need to look into log to find out whether the test case was success or failure. So you want them to have proper assertions so that they are self-validating. And then they should be thorough, as in they need to be testing the happy parts as well as the exception or the uh, cloudy parts. So if like a database is unavailable and all those things, those testings need to happen on unit testing level. Okay, so whenever we talk about unit testing or TDD in general, there are few common resistances which I've always found people come up with, and those are like, my code is a legacy code, I can't unit test. Now, yes, when you're testing legacy code, the things get a bit challenging, but that does not mean you cannot do it. You can have like all the thing that is legacy, you can put it aside, and whenever you're trying to develop a new feature, you can always make that feature like a lotus in a swamp, right? You can make sure that particular unit or the function that you're creating is unit testable, and you can start over there. And then there are some patterns which you can use for testing legacy code. For that, I have a reference later, which is working effectively with legacy code. That's a great book to read. Then they have the excuses that unit tests slow them down, because obviously you have to write more code. But this slowdown is going to pay up later, where you will be able to get the validation that your test case or your production code is still running and you have not caused any regressions. So the price that you are paying while writing the test case always gets paid out later. Then you have the unit tests take a lot of time to run. Again, just like I said, they are not unit test cases if they are taking much time to run. The other common problem that people have is that test cases break every time you change the code. So the reason is that you have coupled your code so much to the production code. The test code is having intimate knowledge about the production code, and probably it is trying to break encapsulation. So whenever you want to move a method from somewhere, you always feel your unit tests are breaking. So that is again a common problem. You'll see me going through refactoring cycles when I'll switch into live code, and you'll see how my test cases don't break at all. Every 5 minutes I'll have green test suite. Don't want developers to do the testing. I think because people are here, they understand that there's value to this. And sometimes people say they don't want developers to write automated test cases. I think we've busted those myths already. So there are obviously some myths surrounding TDD as well. TDD is the same thing as unit testing. No, it is not. TDD is a workflow where you write the tests first. Unit testing is a means to achieve that workflow. Okay. TDD needs to have test per class or per method. Again, it's a false thing that is going around. It's really up to us how high we want to test. We just need to make sure it runs fast. TDD will help us in replacing the QA. No, it's not going to happen. As I said, all the quadrants of testing that we saw are equally important. TDD serves the developers while all the other things that we saw maybe serve the customer and the others were testing for the utilities of product. The goal of TDD is to increase coverage. Again, a very common thing that we see floating around. No, that's not the goal. If you follow TDD, you will get automatic coverage, but the goal of TDD is not to increase the coverage. TDD will magically lead to good design. It will not. Try it out. You try to give a kata exercise to someone who has just joined the industry, teach them TDD and ask them to create a requirement, I mean a kata for them, for you. They'll come up with a very different design that what you will have, right? So it is possible that it leads to a decoupled design, but it surely will not lead you to a good design. A good design still remains more or less up to your experience, and there's no other teacher better than experience in coming up with good design. Okay, so let's delve into the test-driven development. Tests come first with test-driven development. So it is not equal to test after. If you are writing the test cases after you have written the production code, that is not TDD. So there are some common problems. Why test-driven development has been created in such a way that you have to write the failing test first. There are some common problems with test after. Let's see them. We never see the test cases failing. So you have already written the production code, then you write the test case, and the test case from the get-go starts passing. Now, how do we even know whether the test case is passed? Because of the branch that we were trying to test. Okay, so that's a common problem, and it's really important to get the validation and seeing that the test failed first and then it passed. You see people scurrying around to increase the coverage because they did not follow the test first practice. Tightly coupled code, which becomes very difficult to test because when we are writing production code, we don't really think about whether how or I'll be testing that code. Then you have tests start looking ugly and complicated because of the same reason. You have mixed multiple responsibilities in your unit, and then when you try to test it, you find that your test cases are really hard to understand because they are talking about some random things. Then the tests are treated as backlog or second priority because yes, when we have something running, when the production code is there, why would you wait for it to release? You just release it, right? And you just add your test cases to backlog. So these are common problems which we want to avoid. So let's introduce the TDD cycle. The first important phase where we start is the red phase, where you write a failing test case. At this time, there is no method, there is no class, everything is being started from, so it is like a bootstrap. So you bootstrap your design from your test cases. Once you have set your expectation into the red phase, your test case will be failing, saying that it is expecting X, but it got Y, or maybe you with some exception. Then we switch to the production mode and we write the production code that is required to make that test case pass. And then once we have written that, we switch into the refactor phase. I hope all of you have heard about refactoring. So that is, you make the production code better, or either the test code or production code, both of them, you make them better without changing the behavior. So let's dig deeper into in detail into all the mindsets that you have to have when you're into each of these cycles. So let's first talk about red phase. That is where you're setting the expectation from the code. So you are like, okay, if I'm trying to write a calculator, if I pass 1 and 2, I expect the output to be 3. That is your expectation from the code. You think about the side effects and you think about how you are going to verify them, and you start verifying those side effects. Then a test case serves as the executable specification and living documentation of how your code works. So we need to make sure that each and every method of your test case is like a statement which you can read and understand what you're trying to test. It should not be like you have methods like test one, test X, test API. No, though you don't want that. You want good naming conventions. Now, when you are in red phase, you are setting up a contract between the test case and production code. So you are passing, you're calling X method and you're passing few parameters into it. That is your contract with the production code. Okay, so we need to be careful when we are designing that contract, because every time you break that contract, it's going to cause problem in your unit test cases. So this is very important. When you are in red phase, you need to think very clearly about what is going to be the contract. Now, it is very important not to break encapsulation in order to test. So a lot of times people will add getters and setters into the unit just because they want to test. No, that is not the goal. The goal is to test the side effects of what happens when a unit has gone into a particular state. Okay, so example, if you call thread.start, it is going to go in a running state, and if you call start again, it is going to throw an illegal state exception. So we don't want to validate which state the thread in. You can thread is in. You can just call the start method again and get the side effect of an exception, and then you can verify it. Then a common problem into the red phase is you couple too much with the internals of unit, which makes your test cases brittle. So make sure you're not going too deeper into the internals of a unit. Okay, so when we are in green phase, when we are writing production code, you want to make the least amount of changes and get quickly a green test suite. So you do not want making you should not be making too many changes to your production code when you are trying to go into green phase. Okay, resist the urge to make too many drastic changes. Why do we need this? We need a quick feedback cycle so that it frees our mind from completing the requirement. Once you have completed the requirement, then when we reach into the refactor phase, that is when you think about probably removing the duplication, some obvious smells, clean code practices, and design patterns and whatnot. So all that information, all that thought process comes into the picture when we are in refactor phase. So obviously you can apply a lot of refactorings over there. We'll be applying a few today, so you'll see everything happening live. Most importantly, the test cases must remain green after this phase. So suppose you have made a few refactorings and you find that your test case is failing, which means you have unintentionally broken some behavior. So you want to stop over there, make your test cases green again by modifying whatever bug you might have introduced, and then again you go into a red, you start with a new requirement. Now at this in this phase, tests give us the confidence that whatever changes we are making, whatever refactoring we've done, is everything is good to go, and that's why it helps developers to make things better. There is a hidden mindset in the refactor phase where you also want to refactor the test cases, right? You do not want to make them second class citizens. They are also equally important. So you need to look for obvious duplication in test code. You want to encapsulate that in some way. You don't want to make test code too dry, because if you start making it too dry, looking at the test case, you'll never be able to understand what's happening over there. So let it be damp. It is okay if it reads like a statement. Okay, you should not be try to you should not try to make it too dry. Then you can create internal utilities builders that can allow you for easier testing. And again, after this phase, tests must remain green. A very important point: when we are either refactoring the test case or the production code, we should not be refactoring both the things at once, because then we cannot trust. At a time, we need to refactor either the test case or the production code. Okay, so this point is so important that I dedicated yet another slide to it. We must see a test case failing first and then make it pass. If you take this much away from this session, I'll be very happy. Okay, I think I've already touched upon these points, so let's start with the case study. Now I did not want to take a case study that requires a lot of explaining. So I thought Stack Overflow would be a good case study to talk about because it has some interesting constraints. So what we are going to do is we are going to build two features, which is, let's say you are a user and you ask a question. You want to develop a question voting feature where a user can log in and they can click and upvote on a question, and this is like a pseudo user story type of a format that I have created where we want to build this upward downward feature. The acceptance criteria would be like you want the question score to be maintained. So every time you get an upward, the question score should be +1, and every time you get a downward, the question should score should go -1. So at the end of the day, we have score. And at the same time, the author reputation should be increased on every upvote and decremented on every downvote. At the same time, voter upvote and downvote tally has to be maintained. So whosoever is voting, we will maintain a tally of how many upvotes and downvotes they have given. Probably we'll have to show it into some profile page or what. And then the other flip side of the feature that we'll be working on is cancel voting. So suppose if I voted mistakenly, I just want a feature to revert it, and whatever the steps we did while upvoting, we just need to revert all of them. All right, so this is how the demo is structured because this particular example was quite big one, and when I thought of and when I started planning, I found out that I won't be able to live code everything because I need to start from scratch. So what I have done is I have prepared something already, and we have 4 branches which we'll go through, and they are 4 different stages. So from main branch, that is where the basic functionality has been developed, and we'll start working on the question voting feature. We'll cover some path on that branch, and then because the exercise will start getting very mechanical, right? Because we'll be doing the same things again. So I'll switch into a branch where I've already developed the voting feature, and then there you will see that all the acceptance test cases related to voting feature will be passing. That is when we will it will be a time to refactor. Now I did not make any refactorings while doing TDD in main branch. The reason being I wanted to show the process of what happens if you want to make some drastic changes into your code base, and at the same time you want your test cases to be in green phase as soon as possible. Okay, so from voting feature, we'll start refactoring. We will use some design. I'll explain everything when we'll start live coding, and then we'll switch to refactor to use cases branch where I have already refactored that code, but there is still a lot of design smells that that we'll be able to spot over there. So we'll switch to that branch, and from there we'll try to convert it into a rich domain model where all the behavior is hidden inside the classes that need to have the behavior. So I hope you are geared up. What I'll do now is I'll change my machine over to the one from where I'll be showing the live code. So you'll be able to see my screen shortly. Is it visible? Sorry.
Yes, Narendra.
Yes.
All right. Thank you. Unfortunately, you'll not be able to see my webcam right now because I've switched on to a different machine. All right. So right now we are in branch main, just like I said. We have a few acceptance test cases already written. And first, what I'll do is I'll try to run those acceptance test cases and show you that these are the features that need to be developed, and the acceptance test cases for them are failing obviously because the feature doesn't exist yet. So while the acceptance test cases are running, I'll show you the design that we have followed while creating this example. So we have our classic controller service repository kind of a layering where you have a controller which gets a request from the client, and that client payload is not validated. So we use a validator to validate that payload, and it gives me a validated request. Once you get that request into the controller, you pass it down to the service layer. There you have some request objects and DTOs being utilized. And once the domain service has service layer has done its processing, it saves the records into the persistence or the repository. So that's like a classical architecture that we have followed over here. And let's look at the test cases. So as we can see, there's only few features that are passing. So just one sec. All right, I may have to restart my Docker, just container. All right, let's run them again. So the acceptance test cases is something that you want to test the system as close to production code environment as possible. So I have the Docker container set up. So everything is happening like a in a real Spring Boot application. So there is this HTTP client which sends a request to my application, and the records are persisted into the database. So that is how the acceptance test cases have been written. So this is like a fairly black box type of testing that I'm doing. Okay, so if we just filter out the failing test cases, we'll see that the features that we are going to work on, all the acceptance test cases are failing right now, and they are saying that they are getting a 404. Rightly so, because we don't have any controller that is going to solve that request. So that's what we are going to start now. Okay, so obviously the first thing that we need to start with TDD is to start with the test code. Okay, so I have this API package where I have a question. Uh, okay, in API package, what I'll do is I'll create a new package called vote, where I'll be creating my vote controller. So the first thing that we need to do with TDD is to create a test case. I'm going to call it vote controller should. Now, the vote controller will have to validate the incoming request, and when it validates, it needs to pass it to the service layer. Okay, so let's try to write a test case for that. Now the vote controller. Okay, I forgot to show one more thing. Let me show you the APIs that we'll be developing. So we'll be working on the vote controller, and over there we have to create two APIs. One of them is going to be a post endpoint. The other one is going to be a delete endpoint. The post endpoint is structured like you have API v1q followed by the question ID as a path variable and votes. There we'll send a post request. We have to send two arguments. One of them is user ID, that is the send as a header. In a real application, you will have some kind of a auth token being passed, but I have kept it very simple for now. And then you have question ID coming as a path variable. What is the request? We need to send what type of vote we are trying to give. So either it will be an upvote or a downvote. The response is going to be a 200 OK, and it will return you the current score of question. So if there were two upvotes and one downvote, the current score would be 1. Same way, we have to develop this delete API, which is like the exact same URL, but delete method, which is going to delete users vote. Okay, so first things first, we know that the contract is like we need to return a score object. Once we'll get that from the service layer and we'll pass it down to the user. So the first thing that we'll do is it returns the score core object. Okay. Now, because I'll be using mock, I'll use Mockito for this. And now what I'll do is I'll try to create an object of my vote controller. So vote controller. Now the object, I mean, the class doesn't exist yet, but I'm still going to create it because that's what Td says you to. Vote controller, pardon. Okay. Now my vote controller, as we looked into the design, will have to have access to a validator. So I'll have to create a validator which I'll pass into this vote controller. Okay, so let me try to create a class that will be called a vote request validator, payload validator. This class doesn't exist yet, but it will come into the picture as soon as we make this test case pass. So this object will get passed into this vote controller. And then the other thing obviously I'll need is a service object. So here what I'll do is I'll work with the question service object that is already present, because voting is a feature that is very close to question. So I thought it makes sense to keep it in question service. Okay, so again, I'll have to pass this dependency inside the vote. So what I'll do is I'll use inject mocks to get that done from me. Vote controller. Okay. So now once we have that, what I expect from a validator is when I send it a payload, it should return back to me a validated vote request. So we'll need two objects. One is vote request payload. Now this payload object should have some kind of a method where I can set this type. So for now, we'll test it with apport. Okay, so once this is done, I'll pass it to the validator. So I'll have to train the validator. So we'll be using BDD Mockito here. I'll say given the vote request validator dot validate, I'll have some method called validate inside validator. And when I'll pass it the vote request payload, it should return me a valid request. Okay, but I don't have a valid request yet. So let's create it. Vote request. Okay. Instead of doing that, what I have already done in this workspace is I have a method called valid where I'll pass in the vote type dot up. Okay. Everything will get clear. This is like a basic setup. Once this test case is complete, you will get a lot of clarity. Okay, but for the time being, what you should be focusing on is understanding how I'm setting up a contract. This is where I'm designing the structure of my code, and I'm setting up a contract with the production code. So I'll be calling my vote controllers or question vote method, where I'll pass it the vote request, as well as I'll need to pass two arguments that were being passed to us. One of them was user ID. So I'll pass user ID dot validated some user ID. And then what we need to pass is question ID dot validated. These are value objects that I'm passing. So this is just to make things much clearer when we are working into the service layer. Then you need to pass question ID. Okay, once I've done that, the question object, the question or the vote controller should return me the current score. Okay, and then finally what we need to do is we need to assert that the score object is same as the object that was passed to be my service. Oh, I just found out I have not yet trained my service. Okay, so the question service will have a method called question vote, or let me call it something like vote up. And over there, I'll be passing the same user IDs that I have here. Now, you might be thinking everything is red. When are we going to go into a first green phase? Writing a first test case is going to take a bit of time. So we'll say it will return a score object. So I'll need to create score over here. I'll put any value over here. The value doesn't matter for when we are testing the controller. Okay. So now I think we have all the setup that is required. So let's try to create all the classes that are there. First, we need a vote request payload validator. It will go inside the production code API, and there I'll create a package called vote, and there I'll create a class called vote request payload validator. So this is done. Then we need to create a vote controller. It will again go inside the production code. Yes, inside the vote. Right, we have a controller. Now we need a payload, which is the unvalidated portion of the request that's coming from the client. Again, it will reside inside the API package. So that's done. It should have some kind of a set method. So what I'm doing is I'll be using Lombok library, which allows me to create objects fairly easily. I don't need to create the constructors or the getter setters. So it should have a type string, okay, which is the type of vote that that the user is trying to give. Then you have this vote request. Now this vote request is a validated portion. So we'll create it inside the domain layer. So inside my domain layer, I'll have a package called vote. And over there, I'll create this vote request. Not inside API, domain.vote. We have a vote request. It should have a valid method. With that, I'm also going to create a vote type enum, which is going to tell me what type of vote we are giving. So there'll be two types, upvote and downvote. See, I'm having to I'll have to do a lot of setup. So this is where I'm designing my code. I'll have to create a constructor. Well, yes, assign it to a field which should be public. Okay, because you cannot modify a string. Okay, now we have this up type, and now we need to create a method in vote request that will provide me a validated object. So I'll return a new vote request, and I'll provide the argument over there. I'll create this constructor, which I want to keep private. And don't want to delete it. I want to name it type. Okay, so we have a lot of setup done. Now we need to create a method inside validator that's called validate, and it will provide me a vote request. Okay, but now we are not going to put any behavior over there. So I'm just going to say unsupported operation. And then it will return me a valid request, which is the vote request object that we created. And now I need to create a class core, which again will reside inside the domain layer. There I'll create a package called DTO, because it's going to be passed back to the web layer, and it will pass it to the client. So score object is again going to be a data object, which will have a private in score. So now finally we have come up to let me create these constants first. Any user ID. So I'll create a constant and I'll keep it 1. Next, what we need, let me put annotation over there. Okay. Next thing we need is a question ID. I'll create a ID for it. Let's name it Q1. Now we don't have a method called vote up. So we'll create this method. It should return a score object. It will provide me a user ID. And it will provide me a question ID. But again, I won't put any behavior in here because I don't have a test case which tests for that. So I'm just going to say unsupported operation. So this is now compiling. The next thing that we need to this is like I'll name this one as the expected score. and this is the score that I'm getting back from the controller. Here, what I'll have to do is I'll need to pass the user ID, the question ID, and the vote request. Not the vote request, my bad. It should be vote request payload. Okay, because this simulates like a real HTTP application that will be coming to us from the Spring framework. So now I'll create this method, keep it everything as is, just write a unsupported operation exception. Okay, finally, we have something that is compiling. So let's try to run this test case. And obviously, because I don't have any production code, it is going to fail on me. And it's going to say that question vote has not yet been implemented. So I need to start implement the question vote method. Okay, so what's the first thing that we can do? We need to return the score object, which is being returned from the service. And I need to get a validated request from the validator. So the first thing that I have to do is get the dependencies that I have. I'll generate a constructor and I'll add the dependencies that I want, which is vote request payload validator. I'll name it validator for short, and the question service. So this is where you need to think about the dependencies that you are adding inside your class. The moment you think there are too many dependencies, that is where you have to think of redesigning or refactoring after your test cases are passing. So now I have those objects with me. So what I have to do is I'll need to go to the validator and ask it to validate the vote request payload. It will provide me a vote request. And then I can go to the service and ask it to vote upon a question, and I'll pass the validated user ID. I'll pass it the question ID dot validated question ID, and then I need to pass the request. Okay. It's going to throw exception because there can be issues with the IDs that we are getting for the client for the time being, because we don't have scenarios for that. I'm going to ignore those failures. I'm going to assign it to a okay, refactor. All right. So once we get this score, what we need to do is we need to say response entity dot okay, and the score needs to be passed back. Okay. There's one thing that I did incorrectly, which is I did not expect a response entity. It should be a response entity of type score. What are the two things that I expect from my controller? I expect that the controller or get status code should be equal to the HTTP status dot okay, because this is a valid request. And the other thing that I expect is the response dot get body should be equal to, or I can say it should be same as, let's do is equal to, because we already have a expected score created. All right, so this is the contract that I have set up with the production code. Let's try to run it. And the test case is passing. Great, we have first failing test case. It took me a lot of time to go through this setup because everything was being started from scratch. I just wanted to show you the process, and there are a few objects that we also need to be worked with. All right, so time to write next test case. Right now, I'm going to resist from refactoring this test case because I still don't see the repetition that is going to be there into other test case. So let's try to write another one. The next thing that I expect is it should return 400 bad request when either the user ID is invalid. Okay, so in order for me to simulate this scenario, my validator, I know that my validator is going to validate. And the way I have designed things is validator can throw a bad request parameter exception. So what I'm going to do is I'm going to simulate that my validator will throw a bad request parameter exception, and then we'll validate whether the controller returns me the proper response code. Dot validate. Okay, so now here I see I need to redo the things that I have done here. I need to create a vote request as well as a vote request payload. So that is when I can create a setup and move this code over there. Okay. So I have to create these as fields because I want to access them in my test case. Okay, once we have done this quick, I would say restructuring, then I can say when, okay, vote request payload is going to be, it will throw a bad request parameter exception dot class. So this is where I'm training the validator to throw an exception. And once that's done, I'll call my vote controller and I'll call it with the arguments that I am passing in, which is user ID, question ID, and the vote request payload. Now what I expect from the response is that the response should be, I'll copy this over here. And I expect that my response should be bad request. Now, because we have not done any exception handling here, it is going to throw up on me. And I know it's going to throw up on me for one more reason, because I have not declared this checked exception. So I'm going to just skip that step. Okay, let's try to run this test case now. All right, it is failing on me and it's saying that I got an bad request parameter exception. Obviously so, because we have not handled the exception. So let's do basic exception handling. I know we could have created Spring exception handlers, but we want to stay very lean and agile over here. So I'm just doing the classical thing. So I'm just gonna say return response entity dot bad request. Okay, now my test case should pass. Awesome. We have all the test cases passing for the controller. Similarly, we could do it for all the other parameters that we were passing, but I'm not going to go through all that process because it's really similar. So now I have my controller created, but do you think it is a Spring controller? No. So which test will tell me whether it is a Spring controller or not? Either you can write a Spring mock MVC test case, but in my case, I've written acceptance test cases, which will run and send a request. And if the controller doesn't exist, it will still tell me 404. So I know they are going to fail. So what I'll do is I'll start adding the annotations that are required. So it will be a REST controller and it will have a request mapping of /API/v1/q. And over there, the question vote is going to have a post mapping and there I'll have the question ID and it will be /votes. Okay, and I need this parameter which is going to come from the header, and then I have this question ID which is going to come from the path variable, and then you have this payload which is going to come in request body. Okay, so this gives me my controller. If we look at the test cases, you will find that it is still failing because of 404, which means we still don't have a Spring controller. Now this validator is complaining because it is not a Spring bean. So I'll add this bean annotation over there. What did it? Oh, I didn't want to do it that way. Where is it? Alt F1. I'll create a vote configuration. And it's going to be a Spring configuration. And over there, what I want to do is I want to return a bean called create vote request payload validator. And Oops, my bad. I did something really terribly wrong. So it should have been, it returns a vote request payload validator. Okay, all right. So now it's a bean. Let's try to run acceptance test cases again. Now what will happen is, because I have not implemented this validate method, what we should be seeing is we'll get an unsupported operation exception from acceptance test casing layer, and it will tell me that you have not yet implemented validate method. So that is when we are following the outside in design. We created the controller and now we'll start working on the domain layer. So as you see, we have a service up and the controller up and running, but the validate method has not yet been implemented. So this is where you want to start validating. And in order to first write the production code, we need to create a test for it. And I'll name it should. All right. So again, you go through the same cycle that we followed just now. So you'll add whatever validations are required. You'll simulate all the things over here. And finally, you will have a validated request. Then you would pass that request to the service, and we'll then, if you get it working, let's say I skip that validation step for now, and I'll return a vote request dot valid, and let's say I hard code the thing because I just want to show you the process. Okay, so assuming that my validator has been created, let's say if I run my acceptance test cases again.
اصحاب التحفيظ يعني تسويه يقول لك سوي فلوسك بعدين احنا بنحاسبك. سوى
Narendra, you are on mute.
So sorry. Were you able to hear me? I mean, what did I miss? I mean, I was talking constantly. I didn't know I was on mute.
Last 20 seconds or so.
Okay, okay. All right. So I was saying that I ran the acceptance test cases again after completing the validator. Then you'll see that the question service starts blowing up and it says that you have not yet implemented this feature. So that is when we get a trigger. We need to start working on the service. You'll go inside the, you'll create a class. For me, it is already existing because I have already some features built in. So you'll start adding a new test case for the upvoting feature. So let's say question upvote should, and then I'll do the same things that I did with controller. So I'll set my contract, I'll call the vote method on my service, and I'll expect that the score object should have incremented values. Because I don't have that much time to go through the full cycle, what I'll do is I'll switch over to my branch, where I have already set up everything. Okay, so let me stash these things and I'll switch over to my branch voting feature. All right, so here, as you'll see, we have this question voting should, which we were trying to build in previous branch. And here you'll see that I have a test case for voting feature. There, what I'm doing is, for my voting feature to work, I'll need some inputs that I'll need a question, I'll need a voter, and I'll need an author. So I need to look them up from the repository. So those all objects are my dependencies. So I'll mock them. So what I've done is I've trained the mocks to return the objects that I have built over here. And then you send a request, I mean, you call your service and you call your method over there, pass in the arguments that are required. What you expect is the score should be incremented by 1. So in my case, the question had already had score of 10. So it will have the value of 11. Now, probably if I'll write it again, I'll not keep it that way. I'll create a constant for it, but it drives the point home. So let's look at the question where I have created it. Yeah, so here you see that the question already has a score of 10. So when I upvote, I expect that my service should return score of value 11. Now, you also have to pay attention to the naming conventions that I have used over here. All the methods that I have in my test case point to a requirement into the specification. We had these exact same acceptance criterias. So I had the criteria that my score should be incremented, my the upvote counter of voters should be incremented, and the score of question is incremented, as well as the reputation of author is incremented. And all these micro test cases are testing for that exact same thing that I expect my service to do. So that is how you write the test cases. Okay. So now in this branch, what I want to show, can somebody give me a heads up on the time that's remaining?
It's 3:30 already, but I mean, it's 3:33, but I think you can take your time.
Okay, let me take a few more minutes because this is where the juice of the talk is. I wanted to go through one or two refactoring cycles and show you that the test cases can still remain green. You just have to make sure you take the steps in a ordered fashion. So in my case, I have a lot of test cases that are written for this service class. But this service class, as you'll look, has a lot of methods. So it has a lot of dependencies as well. So I'm thinking I need to refactor this class, but I need to refactor it in a way that my test cases should not be affected that much. I want my test cases to be passing every 5 minutes. So how can I do it? What we are going to do is we are going to refactor this design and start using the use case classes. So this is the design that I'm going to refactor it to. My controller layer remains the same. My domain service layer is going to, instead of putting all the code over here that I have already, there are like 220 lines. I want to refactor it. And what question service is going to do is it's going to delegate all the use cases to use case classes. Okay, so basically what we'll do is we'll from this one class there will be 4 or 5 child classes that will be born, but and we'll shift all the test cases that were related to that feature into the test case for that class. Okay, so everything will be done using IntelliJ. Very less steps that I'll have to do will be manual. So the first thing that I'll do is I'll use refactoring and I'll extract a delegate out of this class, and I want to call it post question use case. Okay, and it should be a nested class for now, and I'll select all the things that are required and I'll refactor. It says it needs getters, but I'm just going to ignore it for now. And as you'll see, all the methods that were inside over here have shifted into my delegate. Let's go inside here, and you see this is a class created automatically by IntelliJ. I didn't have to move a bit. Then the only thing that is incorrect over here is the question service is being passed. I don't want that. What I want is I want the dependencies to be explicit. So I need a question ID generator. Gen ID generator only if I'm able to spell things. Okay, so I need to create a parameter for this. It's going to be a field and it's going to be a ID generator. Okay, then you need a clock instance because it creates an instance. I mean, it assigns some timestamp to the questions. I'll create a field clock. Okay, so the next thing that we need is a question repository. Right now, because I am doing this thing, my test cases will be failing, but my goal is I should be in green stage as soon as possible. Yeah, I needed to create that field and it should be question repository. Okay. And we need a tag repository because a question can have tags. I'm trying to be as fast as possible. Okay, and then we need a ID generator for tag. So this is where I have to figure out what dependencies my use case has. And the last thing I think already have is a tag repository. Okay, so now I have all the fields created. What I'll do is I'll generate a constructor. Will not take a service, but take all the other arguments. We don't want service to be passed inside. Okay, so we have an error in the main class, which was the question service, because it's trying to pass itself. That constructor is not going to work for me. So I'm just going to say dot post use case is equal to new post use case. I'll pass all the dependencies, that is question ID generator, clock, question repository, tag repository, and the ID generator. Okay, so now with this, I should have my test cases passing again. So it did not take me more than 5 minutes to get into green stage. What I have done essentially is I have created a class that I can see being injected into the question service, and question service not having to worry about this logic. Okay, so the next refactoring we'll be doing is extract this class outside, not make it an inner class, and like create a proper class out of this. Move it to upper level. I'll move it to a package called use case. Add, all right, we have this class created. And there were a few things that I need to, what did I do? I think I created inside post question use case. Oh, that is not what I wanted. Somehow I created it inside the acceptance test source. So question service, I'll undo. All right, so I'm going to do that again. Move it to upper level. It should be inside, not inside the acceptance test, but inside the main source code. All right. Now I should have it created. Inside domain, I have question, and there I have use case, and this is my use case. Okay, so now we have moved the use case out. We still should have passing test cases. We just have to get rid of these accessors which are not required anymore. All right, so again we have a green test suite, not more than a few minutes. Now the next thing that I need to do is move the test cases that were written inside the question service and move them outside to a class called post question use case should. Okay, so let's go to the test cases for question service should, and over there you have this nested context. I'm going to move it outside because it's going to be a test case in itself, and I'm going to call it post question use case should. I don't want outer parameter to be passed. All right, it needs a lot of setup. Okay, so we have this test case, and now it needs a few things that it was using from this question service should class. So for the time being, what I'll do is I'll pass all the constants. I'll copy it because we need to think of refactoring the test code only after we are in green stage. Right now, I'm not in green stage, so I want to be as quick as possible. I'll have to pass a few mocks as well, so I'm just going to copy them over there. What are the other things that I'll need? I'll need a question ID and a tag ID generator as well, because I know I've created it. All right. So, all right. So there's only one, I think two more errors. Let's solve them quickly. I'll need an instance of clock. Let's go to the top, and there I should have a clock object. It needs to be a fixed clock because I'm writing unit test cases. You do not want external dependencies of time in your test case. So the clock is going to be a fixed clock. All right. So the last thing that I'll need is question service. Instead of question service, it's going to be the use case class now. And the last thing I need is a request. I have this created over here. I'm just going to copy it over here. I'll need to create a field for it. Right. I think I did not put all the constants. Okay. Now, as you see, we are again in. What did I do wrong? I did not have to put it here. So sorry. I'm just trying to be as fast as possible. All right. I think I put the request over here, which was not intended. I need to put it inside the setup. And I'll need my request. All right. So what do we have here? Okay. All right. The final thing that I need is to create an object of use case. So I'm going to create my use case over here is equal to new post question use case. And it needs all the mocks that I generated. Clock, question repository, tag repository, and ID tag ID generator. All right, we should again have passing test cases any moment. All right, let's run them. So essentially what I've done is I've moved all my test cases that were written inside the question service. And again, we have a green test suite, right? So just like this, we can refactor our code without causing too much harm to our test cases. And now the further thing that I can do is instead of creating a new instance here, I can inject it from outside. So from my question service should, I'll first pass the dependency from here. So I'll create a mock for my post question use case. All right. And I'll put it over here. Because I need to inject that dependency. The test case is going to complain. And I'll refactor it, add that argument inside my service. And now the service accepts the use case. I can assign it to a field. Yes, I want to use an existing field. And I don't want the new to be here. So I'm just going to remove it. There's one more error that we need to resolve that is inside the question configuration, because now I need to inject that bean inside my question service class. So I'll create a bean called question use case, and there I'll have to pass all the parameters. I'll start creating the parameters. So everything is being done for me by IntelliJ. If you know how to use your tool well, it will be fairly easy for you to do these refactorings. Just like that, I have a bean created, and all I need to do now is to inject it over here. So I'll again create a parameter and I'll refactor. All right. So now my unit test cases should be passing, as well as my acceptance test cases should be passing, because I've done such a lot of changes on Spring level. I want to validate that my acceptance test cases should not be affected because of the refactorings that I did. Now, this is one more point that we need to be very careful of. If you notice that my unit test cases run in order of milliseconds, right? But my acceptance test cases take a bit of time. So the first order of things is you should be running your unit test cases as frequently as possible, and your acceptance test cases will only run when you have completed your feature, right? So as you can see, only the answer voting feature is remaining. That is an exercise I've left out for you. I'll share my GitHub link. So from there you can pick this up and you can start working on answer voting feature and follow all the steps that I have been following. So just like we extracted one use case, I could extract all the use cases, and then we'll end up in a state which I'm just going to show. And now you can like stop me wherever, whenever the time is like we are going too much out of bounds. So
we can wrap up, Narendra, in the next 5 or 7 minutes, if that's okay.
all right, sounds good. So after doing all the refactorings that I showed you, if I keep doing that refactoring multiple times for all the use cases that we had, we'll end up with this design. Now my question service, if we open question service, does not do anything much. All it does, it delegates all the responsibilities of a particular use case to a use case object. Okay, so with that, my service layer becomes really a simple thing. So I can even decide not to have test cases for the service layer. Again, that's an important point. We need to focus on the behavior when we are doing TDD, on not really on the methods or the number of classes per se. We should be focusing on the juice, that is the domain logic we have in our code base. All right. So once we have this, we can still go on. Like one of the common problems people have is they complain that whenever they change their source code, they have problems with failing test cases. So the important point to understand over here is, if we go inside the voting feature use case, is all the details that are inside this class should always be internal to this class. We should not assume anything about these things when we are writing unit test cases or doing TDD. So that way you decouple yourselves from the design of the class or the unit or a component that you are testing, and you can do refactoring fairly easily. So let's say if I wanted to move this check and extract it inside a method, I could do it and run the test cases and they'll still be passing, right? So I'll share the source code. You can go through it. There was still a lot of information that could be given, but unfortunately, I don't have that much time on my hand. Yeah, so what I'll do is I'll share my presentation again. I'll switch over to the other machine where I was presenting from, and we'll wrap up in next 5 minutes. Okay, unfortunately, I'm facing some issues moving over to my other machine. Somehow it's not opening up. So to summarize, what I wanted to say is that if you want to be successful with TDD, you have to not just dogmatically start writing test cases for all the classes or all the methods that are there. What we need to do is be careful with the design decisions that we are making and try to decouple the test cases as much as possible from your production code. That way it will allow you to refactor your code mercilessly, and obviously you'll end up with in a better state every time you want to release a newer version, or a developer is working on a feature. They will get immediate feedback as to whatever changes they are making, are they valid changes, or we have broken the code that we had written previously. So you get regression bugs being caught up into the unit test cases. So yeah, just one sec. I'll try. Okay, so there are some pro tips that I'll leave, and then we can end this session. So there are anti-patterns which I've seen in my personal experience, is that people run after the coverage. The coverage is not the goal. Stay very clear of the goal, that coverage will not help you. It is the test cases, good test cases, that will help you in future. You want your unit test case to run with each PR and CI builds. If you don't integrate it with CI builds, you'll not get the feedback if you are pushing bad. The developer should be running unit test cases on their local machine, and the test cases should not run take ages to run. If they are taking that much amount of time, they are not unit test cases. And make sure you create a culture where test case failure takes the highest priority. Test through stable abstractions so that you don't couple yourself with the code. And yeah, while refactoring, take small steps just like we were taking, and make sure you are reaching into the green phase after every few minutes, or 5-10 minutes. Yeah, so I think that's pretty much it. I could go on and on, but obviously we have limited amount of time. If there are any questions, I would love to take it.
Narendra, not a question, but more of a discussion or food for thought, that every time when we end up using mocks, right, it almost feels like we're testing the implementation and not the behavior, like what method is being called or how many times a certain method is being called. What are your thoughts on that? What's the right balance of using mocks versus actually just testing the behavior?
That's a great question. So there's a good guideline that people can follow. You do not want to mock the classes which form like a composite object. So let's say your object requires a few other objects to complete its job, but if it is not a dependency, so let's say you are depending on repository, so you do not want to go to a real repository. Either you need to fake it or you need to mock it. But if you are, or else let's say if you're dependent on the services of another module that is out of scope of your testing, you want to mock it. So generally people think that they need to mock all the classes that are passed in as dependencies. So you want to stay clear from that guideline, and mainly it is going to be an experiential thing. It's difficult to put in words. But the point that you were saying about testing the number of times something is called, we only do it for the cases where it's important for us to know how many times something should be called. So let's say if you were testing a caching feature, you would want to make sure that your DB repository is called only once. So your cache is working as it is supposed to. Once the value is cached, you don't want the repository to be called multiple times. So that is when you want to include all those advanced features of mocking.
Correct. Thank you so much, Narendra.
Yeah, more often than not, you'll just have to keep this guideline in mind, that you do not want to mock the internals of your own domain. So what in my example, just like you saw, initially I was mocking the use case, but then in the refactored, I removed the test cases for question service altogether, but because it was not giving me any feedback, or it was not useful for me. So we don't have to write the test cases for all the classes that are there, only test the business logic. And I was only mocking the external boundaries. I was only mocking the repositories. For a controller, a service becomes a boundary, because a controller's responsibility is only to serialize things and validate things. So that's why you use mocking as a design tool instead of, like, I was not mocking domain classes. So essentially that's what I want to say.
Understood. Got it. Thank you so much, Narendra.
Yep.
Hello. Hey, Narendra.
Hey, Rishabh. Yeah.
It's actually, I had a question upon whether or not should we test implementation. I mean, the
Mhm.
general guidance is that, I mean, implementation is a very variable thing, right? One day we
Right.
are using one library and one framework, and another day another thing. So whether or not should we write unit tests for our implementations?
I would like to understand the question better. When we are talking about implementation, what exactly do we mean? Is it the implementation that I've done I'm talking about, or is it like the external libraries that I'm using?
So let's say we are testing our view model, right?
Mhm.
And we are testing some method, and let's say we apply this assertion that our certain method in the repository is called this many times, right?
Okay.
So in the future, I mean, we can have some change in the business logic, and the method will also change, right? The number of
Mhm.
calls can also change, right?
Mhm.
So whether should we test these kind of implementations or not?
So yeah, so whenever we are talking about the things that my implementation will change, or the behavior of my unit is going to change, then if we are following the TDD cycle, we would first change the test case to make sure that the repository is going to be invoked twice, or let's say save, I'm not going to call save method, I'm going to call update method. I'm just giving an example, but that's the test case is going to test for that changed behavior first, and then you will make sure your production code changes, right? So I think yes, there's value in testing it, but when I'm talking about internals, I'm talking about the objects or the helpers that you create inside of your domain service. You do not, at least you should try not to mock them. If it is particularly something you're working on an algorithm which is unpredictable and you want to mock it in order to test the rest of the logic, it's a decision that we have to make. But at the end of the day, it's really depend on the domain and the exact use case that we are working with. So that's why we really need to be very empathetic to the production code and the source code as well. Any second we see some problem popping up, we should regather and regather our strategy and work around it.
Cool.
At least that's the way I've been practicing it.
So I mean, I guess this has been a very debatable topic in terms of how people are. Some people, I guess, do prefer testing only the behavior, and they do not go for those private tests, or let's say tests that you test that basically test the implementation. So I mean, yeah, thanks,
Yes,
thanks for that. Yeah.
yeah, that criteria, even as I said, it's a clear-cut criteria that you should not be testing the internals, but it always has a star mark. It really depends on the domain that you are working with. If it demands you to do, the only option left is to actually do it. Mocking is really a interesting, I mean, it is a very helpful tool if we use it properly.
Yeah, definitely.